Hello, welcome back to my channel. Today I'm going to go through section 2 of the Bmat 2019 paper. This is a 30-minute exam consisting of 27 questions. If you find this information useful, please like and subscribe to this channel. Now without further ado, let's start answering the questions. Question 1. The diagram shows some stages involved in genetic engineering. Which row correctly identifies W, X, Y, and Z? So this question can be answered through a process of elimination. So starting off with W. W is a gene, not a chromosome. We want to have a certain portion of the chromosome cut out so that could be inserted into the plasmid. So immediately we can eliminate A, B, C, and D. Now moving on to X, as I was mentioning before, we cut out this gene, and what we use to cut out genes, we use restriction enzymes. So we can eliminate F and H. Moving on to Y. Y is a plasmid. A plasmid is the genetic store of a bacterium. We don't insert the gene directly into the bacterium. We insert the gene into a plasmid, and then the plasmid is inserted into the bacterium. So we could eliminate G. And of course, Z is ligase, because that's the only one remaining, but also ligase is used to stitch up the newly inserted gene into the plasmid, and therefore our answer is E. And we can move on to question 2. Question number 2. A cleaning solution is used to remove limescale, CaCO3, from bathroom surfaces. When the solution is sprayed onto the limescale, effervescence, fizzing, occurs and the solid limescale begins to disappear. This chemical reaction is needed because the limescale cannot be removed with water alone. Which of the following statements about this chemical reaction are correct? Number 1, the cleaning solution is acidic. Number 2, the effervescence, fizzing, is caused by the release of hydrogen gas. Number 3, the pH of the reacting solution will go down as the reaction proceeds. And 4, the salt produced in the reaction is more soluble than CaCO3. So, on to answering the question. Statement number 1, the cleaning solution is acidic. That is true because calcium carbonate, CaCO3, is a base. It says that it cannot react with just water, so what else reacts with a base and acid? So therefore number 1 is correct. So we could eliminate everything that doesn't have number 1. Moving on to statement number 2. The effervescence, fizzing, is caused by the release of hydrogen gas. This statement is incorrect because when calcium carbonate reacts with an acid, it produces a calcium salt, carbon dioxide gas, and water. It doesn't produce hydrogen gas. So anything with statement number 2 is incorrect. Moving on to statement number 3. The pH of the reacting solution will go down as the reaction proceeds. That is incorrect because the reacting solution is acidic. Acidic things have a low pH, so below 8. And as that reacts with the salt, the pH will actually increase. So 3 is incorrect. And that leaves us with option number C as our answer. I'll still go through number 4. Statement number 4, the salt produced in the reaction is more soluble than CaCO3. That is correct, and you could just read that because it says the solid limescale begins to disappear. So therefore you could assume it's more soluble. And that's question number 2 completed. Question number 3. The diagram shows the forces acting on a cyclist as she accelerates at 4 meters per second on a straight, horizontal section of road. The constant resistive forces are air resistance and 300 newtons force due to friction. The combined mass of the cyclist and bicycle is 50 kilograms. What is the value of air resistance? So this question can be answered by simply solving the equation. So the steps I would first do is determine what equation is going to be used. So you could see force is a variable that they've gave, acceleration is a variable that they gave, and mass. Straight away you should be thinking of F equals ma, where force is the total force in a single direction, mass is the mass of the object or the unit that you're referring to, and acceleration, which is accelerating in a single direction. So now that you've figured out step 1, step number 2 is inputting the values into the equation. So let's start with force. So I'm going to go in the forwards direction, so the force forward. I'm going to put that as my positive side. So I'm going to go 600 minus 300 minus x is equal to the acceleration, which is 4, and the mass, which is 50. So now that I've done step number 2, where I've got an equation, 600 minus 300 minus x, x stands for air resistance, is equal to 4 times 50, I'm now going to simply solve the equation. So I'm going to quickly simplify it down to 300 minus x is equal to 200, and therefore x is equal to 100. And the answer to the question is B, 100 newtons. And that is question number 3 completed. Question number 4. The non-zero numbers P and Q are such that P plus Q is equal to 3, open brackets, P minus Q, close brackets. What is the value of PQ over P squared plus Q squared? Now, this is a simple maths question that needs to be solved. So the first step that I would do is trying to get the P's on one side and the Q's on the other side of the given statement that they gave above the given equation. So P plus Q is equal to 3P minus 3Q. And I'm going to bring the P's on the left hand side, keep the Q's on the right hand side. So that's going to come to minus 2P is equal to minus 4Q. And now I'm going to make the left hand side completely simplified. I'm going to make that equal to P. P is equal to 2Q. Now this is a very important piece of information, because now I could substitute every P in the PQ over P squared plus Q squared equation with 2Q. And that's exactly what I'm going to do. So PQ is equal to 2Q squared. So 2Q squared over P squared. So P squared is open bracket 2Q close bracket squared, which is equal to 4Q squared plus Q squared. Simplify that. That goes to 2Q squared divided by 5Q squared. Straight away you could eliminate the Q's. That leaves you with the answer of 2 over 5. And therefore the answer is B. And that's question number 4 completed. Question number 5. The labels 1, 2 and 3 in the following diagram represents cellular processes. The shaded areas represents processes that can happen without the use of energy provided by cellular respiration. Which processes could label 1, 2 and 3 represent? So this is a question which requires elimination. So straight away I would be thinking that the non-shaded area is an area that requires ATP. So circle number 1 can be active transport or aerobic respiration. It cannot be diffusion or osmosis because they're passive, they don't need ATP. So we could straight away eliminate C, D, and E. Now moving on to section 2, that's a passive section, a passive process, so therefore it doesn't require ATP. Straight away we could eliminate F because that is a passive. That is an active process, and diffusion and osmosis is passive. Now moving on to section number 3, that's also a passive process, doesn't require ATP or energy. So you could eliminate B and G because aerobic respiration does require ATP and it's active, whereas osmosis is passive, and therefore the answer is A. That's question number 5 completed. Question number 6. A chemist used electrolysis to electroplate a pure copper rod with a layer of silver. The concentration of metal ions in the electrolyte was kept constant. Which row in the table identifies appropriate substances used as the anode, the cathode, and the electrolyte? So answering this question, this is going to be an elimination style question where you eliminate as you go to try and get your final answer. That'll be the quickest way how to do this. So straight away, you know that the electrolyte is going to contain silver nitrate. This is because you want to coat the copper rod with silver, and the electrolyte needs to contain the metal ion that you're going to coat the rod with. So therefore, we could eliminate A, B, and C. Now, moving on to the cathode. So the cathode is the negative electrode, and at the negative electrode, the metal ions are going to gain an electron and become a metal, and that's where the metal is going to deposit, the coating is going to occur. And we want to coat the copper rod. So therefore, the cathode has to be the pure copper rod. So we could eliminate E. Now, finally moving on to the anode, which is the positive electrode. The anode's purpose in this form of electrolysis is to replenish the silver ions that's in the electrolyte and provide electrons. So at the cathode, the metal ion can be turned into a metal by gaining an electron. So therefore, we need to replenish not only the electrons, but the metal ions for the electrolyte and the cathode. So therefore, the anode is D. It's not F. Graphite has nothing to do with this. So our answer is D. And that's question number 6 completed. Question number 7. A measuring cylinder resting on an electronic base contains a liquid as shown in diagram 1. A small object X is gently lowered into the liquid and no liquid is splashed out of the cylinder. The result is shown in diagram 2. What is the density of the material from which object X is made? So to answer this question, we need to not use the elimination method because we have nothing to eliminate with. We have to solve this maths question. So step number 1 is find out what equation you're going to use for this. And the key equation that we're going to use for this is the equation for density, which is equal to mass over volume. So keep that to one side. And now let's try and work out what the mass of object X is and the volume of object X. So we could input these values into our equation for density and get our answer. So let's start off with working out the weight, the mass. So diagram 1 shows the mass of the cylinder being 750 grams. Diagram number 2 shows the mass being 950 grams. 950 minus 750 is equal to 200. So that is our mass. Now, moving on to the volume. Diagram number 2 shows that the volume is 500 milliliters or centimeters cubed. And on the left with diagram 1, the volume is 375 milliliters or centimeters cubed. Now we're going to subtract the two to get the volume of object X. So 500 minus 375 is equal to 125 milliliters or centimeters cubed. So now that we have our two variables, 200 and 115, we're just going to input it into our equation of density, which is mass 200 over volume 125, and that is your density. We need to simplify it down. You could divide it by 5 and 5 again, and that gives you a fraction of 8 over 5. That could be simplified to 1.6 grams per centimeter cubed. And therefore the answer is C. And that is question number 7 completed. Question number 8, find the value of square root 6 times 10 to the power of 2 plus 4 times 10 to the power of 1 over 1.2 times 10 to the minus 2 plus 4 times 10 to the minus 3. So step number 1 is to try and simplify everything inside of the square root. So that goes to square root 640. Because I use BidMass to simplify the numerator and the denominator. Hopefully I don't need to explain that. If you want me to do a video on that, leave that in the comments, and I can further go through this question and explain BidMass and how to do BidMass quickly in time-pressured situations like the UKCAT and the Bmat. So that's the numerator, and the denominator is 0.016. And now I am going to put this all in standard form. 6.4 times 10 to 2 over 1.6 times 10 to the minus 2. And if I multiply the top and the bottom by 10 inside the fraction, the overall fraction will remain the same. So that will be 64 times by 10 to the power of 2 is equal to 16 times 10 to the minus 2, all been square rooted. Now I'm going to bring all of the times 10 to the numerator. I'm going to get rid of the times 10 to the minus 2 in the denominator by simply removing the times 10 to the minus 2 by changing the top numerator times 10 to the 2 to times 10 to the 4. So just going to continue that over here. So that'll be 64 times 10 to the 4 over 16. And now I'm going to just get rid of the square root. I have two square numbers on the numerator and denominator, so that's very easy to square root. So that's going to be 8 times 10 to the power of 2, because 8 times 8 is 64, over 4. 16 is 4 times 4. And now I'm just going to cancel this 1, put this as 2, because 8 divided by 4 is 2, and 2 times 10 to the power of 2 is 200, and therefore the answer is E, and that's question number 8 completed. Question number 9. A lizard was placed in a chamber with a constant flow of air. The temperature of the chamber was varied between 25 degrees Celsius and 10 degrees Celsius. Apart from the temperature and time, all the other variables were kept constant. The carbon dioxide concentration in the air leaving the chamber are shown in the graph. The graph shows temperature, and as the temperature decreases, so does the carbon dioxide concentration. Which of the following statements is or are correct? Statement number 1, between 25 degrees Celsius and 10 degrees Celsius, the respiration rate of the lizard is inversely proportional to the environmental temperature. Statement number 2, the data demonstrates that the lizard is only respiring aerobically. And statement number 3, the carbon dioxide could be detected by passing the air leaving the chamber through lime water. So now answering the question. This is a question that requires elimination in order to get the right answer, but to be fair, I doubt you're going to need that because this is a very straightforward question. So statement number 1 is incorrect, because as temperature decreases, so does the CO2 concentration. CO2 concentration is directly proportional to the respiration rate, and you could therefore conclude that respiration rate is directly proportional to environmental temperature. So anything with statement 1 is incorrect. So B is out, E is out, F is out, H is out. Statement number 2 is incorrect, as both anaerobic and aerobic respiration produces CO2. Can't really tell the difference. So C is out, E, G. Now we are only left with A and D. So statement number 3 is correct, as lime water turns milky white under the presence of CO2. So therefore A is eliminated, and our answer is D. That's question number 9 completed. Question number 10. Consider the non-radioactive elements in group 1. Which of the following statements is or are correct about the element with the largest atomic number? It has the most vigorous reaction in cold water. Its atom has the same number of electrons in its highest occupied level as the other members of the group. It is the most readily oxidized. So this is a elimination question, and you eliminate as you go along. And now starting with statement number 1. Statement number 1 is correct, because as you go down the group, the atomic radius increases and the outermost electron is more easily lost. As the atomic radius increases, there's more shielding, there's less attractive force between the outermost electron and the nucleus. So statement number 1 is correct. So we could eliminate A, C, D, G. Now moving on to statement number 2. Statement number 2 is correct because they all have 1 electron in its highest occupied energy level. So anything with number 2 is correct. So we could eliminate B and F. Now moving on to statement number 3. It is the most readily oxidized. This is correct for reasons mentioned in statement number 1. This is because there isn't much attraction between the nucleus, which is full of positive protons, and their outermost electrons. So we could eliminate E, and therefore the answer to 10 is H. Question number 11. A large metal sphere mounted onto an insulating stand is negatively charged. A smaller uncharged plate metal sphere mounted onto an insulating stand is placed near to the negatively charged sphere. The smaller sphere is connected to the Earth by a conducting wire. Electrons flow from the smaller sphere to the Earth because they are repelled by the larger sphere. The smaller sphere is then disconnected from the Earth. Which row must be correct about the particles in the larger sphere and the final charge of the smaller sphere? So, immediately let's focus on the big sphere. The information given states that it's negatively charged, therefore it contains more electrons, which are negatively charged, than protons, which is positively charged. So therefore we can eliminate D, E, and F. And now moving on to the smaller sphere. So we know that the big sphere has an overall negative charge, and it causes the electrons on the smaller sphere to be repelled and be conducted down into the Earth. So if all the electrons are repelled off because electrons are negatively charged, that only leaves neutrons and protons. Neutrons have a neutral charge, protons have a positive charge. So therefore the answer is C. And that's question number 11 completed. Question number 12. Point M has coordinates 6, 3p minus 1, and point N has coordinates of 1 minus p, 2. The gradient of the straight line joining M and N is minus 3, and it crosses the y-axis at 0, r. What is the value of r? So immediately looking at this question, I know this is requiring my knowledge of calculating what the y-intercept of a straight line graph is. So I'm going to be using the equation y equals mx plus c. Some people prefer to use the other equation. I find this one the easiest. You can essentially do whatever you want. The outcome is still going to be the same. And we're essentially going to be inputting the gradient that they've kindly given us, which is minus 3x plus c is equal to y. And now we're going to form two simultaneous equations with each coordinate. So we're going to have one simultaneous equation with the coordinates at point M, and another simultaneous equation with the coordinates at point N. So, coordinate point M, I'm going to jump a few steps here and just give the final equation. So, 3p minus 1 is equal to minus 18 plus c. So you could see that the minus 18 is referring to the mx part of the equation, and the 3p minus 1 is referring to the y part of the equation. So I'm going to call this equation number 1 for convenience sake. And now I'm going to do the equation for the coordinates at point N. So I'm going to do the simplifying again. So 5 is equal to, no. 2 is equal to minus 3 plus 3p plus c. That refers to equation number 2. And as you can see again, the y bit is the 2. The mx part is minus 3 plus 3p, and the c is pretty evident. Now what I'm going to do is simplify equations 1 and 2 such that I have the p's and c's on the left hand side of the equation and a integer value on the right hand side of the equation. So statement number 1 simplified and rearranged to my preference for solving the simultaneous equation through elimination is going to be 3p minus c is equal to minus 17. That's our new equation 1, more like saying rearranged equation 1. And now I'm going to give the same treatment to statement number 2. That will go to 3p plus c is equal to 5. So now I'm going to solve this simultaneous equation. I'm going to solve for c through elimination, and what I'm going to do is that I'm going to deduct equation 1 by equation 2. So what does that leave me? So minus c is equal to minus 2c minus, and 3p minus 3p is 0. It's equal to minus 17 minus 5 is equal to minus 22. So I'm going to simplify. C is equal to 11, and therefore our answer to this question is H. And that's question number 12 completed. Question number 13. Which of the following is/are included in the carbon cycle? Amino acids in animals. Statement number 2, cellulose in plant cell walls. And statement number 3, lipids in bacterial cell membrane. So, amino acids in animals are used in the carbon cycle because they're digested by other predators or microbacteria, saprobionts. So statement 1 is correct. So we can straight away eliminate A, we can eliminate C, we can eliminate D, we can eliminate G. And now moving on to statement number 2. Cellulose in the plant cell wall. That is included in the carbon cycle. Other predators eat the cellulose. They eat the plant, they have to digest the cellulose, or the cellulose is digested by saprobionts. So that is correct. Also, cellulose can be waste, the waste part of the carbon cycle. So 2 is correct, so we can eliminate B, we can eliminate F. And now on to 3, lipids in bacterial cell membrane. They are included in the carbon cycle. Cell membranes get digested, they get broken down, reabsorbed, they contain carbon. So 3 is correct, we can eliminate E, and that leaves us with only H. And question number 13 is completed. Question number 14. The decomposition of hydrogen peroxide in the presence of manganese oxide catalyst produces water and oxygen gas. The equations below. 0.2 grams of manganese oxide granules are added to 50 centimeters cubed of 0.1 mole per decimeter cubed of hydrogen peroxide at 20 degrees Celsius. The volume of the gas collected is shown on the graph as curve X. The second experiment is carried out at 20 degrees using the same mass of manganese oxide. The volume of the gas collected is shown as curve Y. And here is the graph. Which of the following conditions could result in curve Y? So immediately I'm going to tackle the manganese oxide particle size column. I'm going to look at the graph. Line Y has a steeper line than X. Therefore, the powder has to be finer than the granules. It has to be a powder. And therefore, we could eliminate D and E. Now, trying to solve the columns referring to the volume of hydrogen peroxide and the concentration of hydrogen peroxide, I'm going to calculate the moles of hydrogen peroxide first produced in X, and then I'm going to work out the moles produced in Y, and then based off that information, I could multiply the two columns together to find out if the answer is correct. I'll walk you through if you don't understand. So, I want to work out the moles of X, the moles of the hydrogen peroxide in X. So how do we do that? Moles is equal to concentration times volume, where the concentration is moles per decimeter cubed and the volume is decimeters. So we're told that it's 0.1 as the concentration times by the volume, which is 50 centimeters cubed, which is equivalent to 50 over 100. And that is equal to 0.005. So that is the moles of hydrogen peroxide in X. Now, we know that the moles of hydrogen peroxide is equivalent to the amount of gas released in both reactions. So now I'm going to look at the graph and look at the difference between X and Y, and then essentially find or make a fraction to solve the answer to the question. So there's 1, 2, 3, 4, 5 blocks for X, and for Y there's 1, 2, 3, 4. Therefore, Y produces 4/5 the amount of moles of oxygen as X, so therefore that applies to the hydrogen peroxide. So 0.005 times by 4 over 5 is equal to 0.004. And now, keeping this 0.004 in your head, we can now refer to the numbers in this column and this column. Now, using the equation that I mentioned above for moles, moles is equal to concentration times volume, where the concentration is moles per decimeter cubed, and the volume is decimeters cubed. We want the numbers, the volume and the concentration, multiplied together to equal 0.4. And I'm going to fast forward through everything to save you guys time. The answer for this question is A. And I hope you understood that. And that is the answer to this question. Question number 15. Which statement about waves is correct? This is an elimination question. You want to try and work through this question as fast as possible to get the answer quickly. So all longitudinal waves travel at the same speed. That is false. That's only in a vacuum. So eliminate that. B, longitudinal waves cause vibrations perpendicular to the direction of energy transfer. That's not true. It's parallel. C, sound waves are transverse. No, they're not. They are longitudinal. D, transverse waves always travel faster than longitudinal waves. That is not true, depending on the wave and a lot of other circumstances. E, transverse waves are all electromagnetic. That is incorrect. All electromagnetic waves are transverse. And F, ultrasonic waves are longitudinal. That is correct, and the answer to 15 is F. Question number 16. One side of a rectangle is 7 minus root 5 centimeters. The rectangle has an area of 66 centimeters squared. What's the perimeter in centimeters of the rectangle? So immediately you should be thinking, how do I calculate the area of a rectangle? It's length times width. You know what the length is. So 7 minus root 5. And we could call the other side x is equal to 66. And now let's solve for x to work out what that one side is. X is equal to 66 over 7 minus root 5. So now we know what x is, and we want to rationalize the third at the bottom. So that will be equal to 66 open bracket 7 plus square root 5 over 49 minus 5, which comes to, if you do all the simplifications and everything, I'm not going to bother to do that because I assume you could do that very straightforward. 21 plus 3 over 5 2. That is equal to our other length x. And we want to work out the perimeter. So we need 2 lots of x and 2 lots of 7 minus root 5. Straight away 2x is equal to 21 plus 3 root 5. And we want the other length, 2 lengths, 2 open bracket 7 minus root 5. That is all equal to 35 plus root 5. And therefore our answer to this question number 16 is D. Question number 17. A pea plant is heterozygous for seed color and homozygous for seed shape. Yellow seed color, big Y, is dominant for green seed color, little y. Round seed shape, big R, is dominant to wrinkled seed shape, little r. Using the information provided, which of the following statements taken independently could be correct? So immediately you should be thinking of the genotype of the 2 characteristics given for this pea plant. Definitely the pea plant seed color is going to be big Y, little y. That is heterozygous, and it's going to be yellow because the dominant yellow is going to overpower the recessive green. Now, in regards to seed shape, it says it's homozygous, so it could either be little r, which is wrinkled, and big R, which means round seed shape. So now I'm going to look at the statements. This plant contains alleles big Y, big R, little r. No. Statement number 2. This plant contains only big Y, and R. That can be a possibility. Statement number 3. This plant contains only big Y, R, and little r. That cannot be the case. The genotype for this plant seed color is big Y, little y. That is correct. The genotype for this plant seed color is big Y. That cannot be the case. The genotype of this plant seed shape could be big R, little r. That cannot be the case. The genotype for this plant for seed shape is little r. That is correct. And therefore the answer is 2, 4, and 7. And the answer is going to be D. And that is question number 17 completed. Question number 18. The concentration of Fe2 plus ions in a solution can be determined by titration with acidified potassium manganate 7 solution. The ionic equation for the reaction is as displayed. A 25 centimeter cube sample of solution containing Fe2 plus ions react exactly with 10 centimeter cubed of 0.05 mole per decimeter cubed potassium manganate 7 solution. What is the concentration of Fe2 plus ions in moles per decimeter cubed? So, straight away you should be thinking about calculating the moles of the manganate ions, and you're going to be using the equation moles is equal to concentration times by volume, and that will come to 10 over 1000. You have to make sure everything's in decimeters for this question, remember, times by 0.05, the concentration is equal to 5 times 10 to the minus 4. That is the moles of the manganate ions. Now look at the manganate ions, the ratio between the manganate ions and the Fe2 plus ions. For every one manganate ion, there is 5 Fe2 plus ions. So we have to multiply this number by 5, which is equal to 2.5 times 10 to the minus 3. And that's the amount of moles of Fe2 plus in the solution. Now we're going to calculate the concentration. So we're told that there's 25 centimeters cubed of this solution. So we are going to do 2.5 times 10 to the 3 divided by 25 divided by 1000, which is equal to 0.1, which is equal to 1 times 10 to the minus 1, and E, and that is question number 18 completed. Question number 19. Cosmologists have deduced that soon after the universe was formed, it was filled with electromagnetic radiation in the form of intense gamma rays. They have also deduced that the universe has been expanding since that time. One effect of this expansion is that the electromagnetic radiation that fills the universe is now in the microwave region of the spectrum. Here are 3 statements about the effects of the universe expanding on the electromagnetic radiation that filled the early universe. Statement 1, the expansion has caused an increase in the frequency of the radiation. Statement number 2, the expansion has caused a decrease in the wavelength of the radiation. Statement number 3, the expansion has caused frequency to change in direct proportion to the wavelength. Which of the following statements is or are correct? So, I'm going to go through each of the 3 statements. This is very straightforward. Statement number 1, the expansion has caused an increase in the frequency of the radiation. That is incorrect because as you go from gamma to microwaves, the frequency decreases. Now moving on to statement number 2, the expansion has caused a decrease in the wavelength of the radiation. That's also incorrect because when you go from gamma to microwaves, the wavelength increases. And statement number 3, the expansion has caused caused frequency to change in direct proportion to wavelength. That will be always incorrect. Frequency is always indirect proportion to wavelength. So therefore none of them are correct and the answer is A. And that's question number 19 completed. Question number 20. To get to work, Sylvie first catches a bus and then catches a train. The probability that the bus is on time is 0.6. The probability that the bus is late is 0.4. If the bus is on time, then the probability that she'll catch the train is 0.8. If the bus is late, then the probability that she'll catch the train is 0.6. Given that Sylvie catches the train, what's the probability that the bus was on time? Step number 1 would be to draw a probability tree or tree diagram. I'm not going to do that because this question is very, very straightforward. Now I am going to write down the equation that I'm going to use and the substitutions for that equation. So now I'm going to substitute my values in. So 0.6 times by 0.8 over 0.6 times by 0.8 plus 0.4 times by 0.6. That is equal to 0.48 divided by 0.72. Immediately you should be thinking, okay, what's the biggest common factor of these two? And that would be 24, well 0.24, and that gives us the answer of 2/3, and therefore the answer to this question is E. That is question number 20 completed. Question number 21. Which of the following statements is or are correct for a healthy human? Statement number 1. A protein section coded for by part of a gene consisting of 500 base pairs will have a maximum of 166 amino acids. Statement number 2. A liver cell and a mature red blood cell from the same person will both have chromosomes number of 46. Statement number 3. The number of adenine bases in an allele must be the same as the number of guanine bases. So this is a simple elimination question, very easy question. Statement 1 is correct because a gene is generally coded in triplets. 500 divided by 3 is 166.66666, and you could only have full genes, so the answer for that statement is true. Statement number 2, liver cells and red blood cells are not the same. Liver cells does have a nucleus, it does have chromosomes, whereas a red blood cell doesn't. So it won't have 46 chromosomes. So 2 is incorrect. 3, the number of adenine bases is the same number of the thymine bases, and the number of guanine bases is the same as the number of cytosine bases. So therefore, the answer to this question is B. Question number 22. Complete combustion of 35 centimeters cubed of straight cane alkane vapor gives 105 centimeters cubed of carbon dioxide gas. Both gas volumes were measured at the same temperature and pressure. Which of the following molecular formula is the molecular formula of the alkane? So straight away, you know alkane. The alkane formula is CnH2n plus 2. So immediately get rid of C, get rid of A, and now we look at the gases. So 105 centimeters cubed of CO2 was produced from 35 centimeters cubed of the alkane. 105 divided by 35 is 3. Therefore, that's the number of carbons present in that alkane, and the answer is D. Question number 23. A water jet pack has lifted a person vertically upwards, as shown in the sketch. He is now stationary at a constant height. There's a diagram. Water rises through the tube and is ejected at a speed of 15 meters per second through 2 nozzles. At a time of 12 seconds, each nozzle ejects 400 kg of water vertically downwards. What is the momentum of the water ejected by each nozzle in 12 seconds? And what is the upward force due to water ejected by the jet pack? So immediately you should be thinking about how to calculate momentum, and momentum is calculated by mass times velocity. So mass times velocity is equal to momentum. I'm just going to scribble that over. Now, I'm going to calculate the momentum of the water being ejected from each nozzle. So they say 400 kg times by 12. That's going to come to 6,000 kg per meters per second. So therefore, I could eliminate D, E, F, G, H. And now I need to work out the force overall. So force, the equation that we're going to use in this case, is the change in momentum over time. So the person was initially stationary, and now the person is producing X amount of momentum. And we're told to calculate the upward force ejected by the jetpack. The jetpack is made up of 2 nozzles. So we need to multiply our 6,000 by 2, which gives us 12,000. That's the momentum of the jetpack, both nozzles. And 12 seconds to calculate the force. So 12,000 divided by 12 is 1,000. Therefore, the answer is A. That is question number 23 completed. Question number 24. A cross-country run track is in the shape of a regular pentagon. There's a diagram of it. Competitors run in a clockwise motion around the track. When on the third leg of the course, they run at a bearing of 110. What bearing do they run on the first leg? So this is a very mathematical question which involves a lot of annotation. You won't be able to eliminate anything in this question. So immediately you should be thinking, what is the interior angle of a pentagon? And it is 108. So let's label that 108. And they gave us the information that this angle here is 110. And then knowing that a circle has 360 degrees, we know that this angle over here is equal to 142 degrees. Now at the second leg, let's also draw another north line. And using the angles of a straight line, we could calculate this is 38. So 38 degrees. And this is 108 degrees because of the interior angles of a straight line. Now we're going to draw another north line here. Hopefully your north line will be better than mine. And I want to work out this angle over here. And how am I going to do that? I am going to do 180 minus 34 minus 108, which is equal to 34. That's that small little slither over here. And we want to work out the bearing from the first leg, so we need this entire angle. So 360 minus 34 is equal to 326 degrees. And that is the answer to question number 24. And therefore, the answer to this question is H. That's question number 24 completed. Question number 25. A student carried out tests to find out which molecules were present in a sample of urine from a human male. The student recorded the presence of large protein molecules in the urine and suggested that this indicated that the kidneys were not functioning correctly. Which of the following could have resulted in high concentration of protein in the urine sample? Statement 1, damage to the cell membranes between the blood vessels and the Bowman capsule. 2, a reduced rate of active transport and selective reabsorption in nephron. 3, cells in the collecting duct do not have receptors to bind to antidiuretic hormones, ADH, and so are unable to respond to the hormone. This is a simple question of knowledge. The answer is B to this question because at the Bowman's capsule you have ultrafiltration, no proteins go in, they're far too large. If they do go in, that means there's a problem there. That's the only point where proteins are involved. Everything after that, so when you're referring to the nephron and the whole reabsorption of ions and water, doesn't really affect protein. So that's question number 25 completed. Question number 26. Diborane has a formula of B2H6. Assuming that boron consists of 2 isotopes containing 20% 10 boron atoms and 80% of 11 boron atoms, and all the hydrogens are 1 atomic weight, molecules of diboron therefore have relative masses of 26, 27, 28. In what relative proportion will molecules of diborane with masses of 26, 27, 28 occur? This is a simple question of ratios and multiplications. So let's go and work it out. So we want to work out first the probability of both borons being boron 10. So we're going to do 0.0 0.2 times by 0.2, which is equal to 0.04. Now we're going to work out the probability of both of them are boron 11. So 0.8 times by 0.8 is equal to 0.64. And now we're going to work out the probability that one boron has an atomic weight of 10 and the other has an atomic weight of 11. Now this is where they try and catch you out, because you could have two possibilities. You could either have boron 10 attach at site number 1 and boron 11 attach at site number 2, or you could have the inverse where boron 11 attaches at site number 1 and boron 10 attaches at site number 2. So you're going to have 2 times by 2 open bracket 0.2 times by 0.8, which is equal to 0.32. And now you could just form a simplified ratio. I'm going to remove the decimal points, multiply everything by 100. So 4 to 32 to 64. That comes to 1 to 8 to 16, because when you divide everything by 4, you get that. And the answer is E. That's question number 26 completed. Question number 27. A 100% efficient ideal transformer has 400 turns on its primary coil and 100 turns on its secondary coil. The input voltage across the primary coil is 240 volts. The output current is 2 amperes flow in the secondary coil. There's a diagram of the transformer being described. What is the output voltage of the secondary coil and the input current of the primary coil and the output power of the transformer? So immediately you're going to work out the output voltage, the input current, and then finally the output power. So to work out the output voltage, you're going to use the voltage of the secondary coil over the voltage of the primary coil is equal to the number of coils on the secondary coil over the number of coils on the primary transformer. So we are going to write that out and solve. So x over 240 is equal to 100 over 400. Therefore x is equal to 60. We can eliminate all of these. E, F, G, H. All of them gone. Now we could work out the input current, and we are going to use the formula V P times by I. P is equal to Vs times by Is. See how everything, all the primaries are on one side, all the secondaries are on the other side. Remember that, it's very important. And now let's do it again. So 240 times by, let's call this variable y, is equal to 60 times by 2, y is equal to 0.5. I'm not going to bore you with the simplifications. I assume you could do that. So now we could eliminate C and D. And now to calculate the output power. And we are going to use the equation P is equal to IV. And substitute I and V. 2 times 60 is equal to 120. And therefore we could eliminate A, and the answer is B. And that is question number 27 completed. Thank you very much for watching this YouTube video. Please smash the like button and the subscribe button if you enjoyed this video. It means a lot. It helps my videos get pushed up further so other people can view it, and at the same time it motivates me to produce more videos as lots of people want to watch it. Once again, thank you very much. Please leave in the comments if you want me to go through anything in detail, or if you have any other Bmat UK CAT related topics that you want me to go through. Once again, thank you very much, and see you next time.